Today we're starting on page 2 of our Chapter 10 notes packet, Section 10.2, trig function values and radian measures. So we'll be learning two things today. Finding the exact value of trig functions first. These are the steps. We're going to draw and label our special right triangles or write and use our trig table to refer to. So I'm going to, over on the right hand side here, draw the trig table. So we have the large square root, top heading of our angle measures in degrees, 30, 45, and 60. Side heading, sine theta, cosine theta. And our first line is 1, 2, 3. Our second line decreases 3, 2, 1. And this is all over 2. Right? So we'll be referring to our trig table. For those of you who prefer the special right triangles, I'll put those over here. My 30, 60, 90. Opposite the 30s, 1, hypotenuse 2, opposite the 60, square root of 3. And our 45, 45, 90. That wasn't a very good representation of 30, 60, 90, but you have the angle measures there. 45, 45, 90, our legs are 1, hypotenuse is the square root of 2. Okay. So we'll use that, leave them there to refer to them. We're going to convert our radian measure to degrees. Right. So first thing we'll do here to sine of 5 pi over 4 is we will convert this radian measure to degree measure. So let's convert to degree measure. Convert to degrees. So we'll multiply by 180 over pi. And if you need to use a calculator, the pi's are going to divide out. I like doing things by hand, so I know that 4 goes into 180 45 times, and 5 times 45 is 225. I don't actually want to put an equal sign there, though. I just want to write 225 degrees. All right, so we have the sine of 225 degrees. Now, we'll note the quadrant and the sine. By sine, I mean SIGN, right? 225 degree angle. Its terminal side would be in quadrant 3, right? Quadrant 3. And using all students take chemistry, an angle in quadrant 3 has a sine value that is negative. So the sine of 225 is going to equal negative sine. And now we need to get our reference angle. So now we're going to write it as a trig function of an acute angle. I'm just writing the symbol for angle instead of writing out the word. In other words, our reference angle. Remember, our reference angles are always acute angles. So this should be familiar. We did this in Chapter 9, our last chapter. Right? Sine of 225 is going to equal negative sine of, since this is in quadrant 3, the reference angle we can get by taking 225 and subtracting 180 from it. So I'm just going to write minus 180 in line with my 225, and this is equal to 45. 225 subtract 180 is 45. Okay, so we have sine of 225 is equal to negative sine 45. Now that we have our acute angle, what is the sine of a 45 degree angle? We look up at our trig table. Sine of 45 is going to be square root of 2 over 2. So our answer is square root of 2 over 2. And let's bring down the negative. So negative square root of 2 over 2. That's our exact value. All right, next, number 2, cosine 11 pi over 6 will convert to degree measure, timesing by 180 over pi. And these will divide out. I know 6 goes into 180 30 times. 30 times 11 is 330. So this is equivalent to cosine of 330 degrees. A 330 degree angle, terminal side, lies in what quadrant? Quadrant 4. In quadrant 4, is cosine positive or negative? It's positive, so this is going to be equivalent to positive cosine. I'm not going to write positive though, just cosine of our reference angle. To get our reference angle, in quadrant 4, we would take 360 and minus the 330. So our reference angle is 30. So cosine of 330 is equivalent to cosine of 30 degrees. Now evaluate it. Cosine of 30 degrees, square root of 3 over 2. So this is our exact value. Right? So the cosine of 11 pi over 6 radians has an exact value of square root of 3 over 2. Next, tangent of 5 pi over 6. The 5 pi over 6 will convert to degrees, multiply by 180 over pi. I just love fractions. 6 goes into 180 30 times. 5 times 30 is going to be 150. So this is equivalent to tangent of 150 degrees. 150 degree angle, its terminal side lies in quadrant 2, and tangent is negative in quadrant 2, right? All students take chemistry, just sine is positive. Well, sine and its reciprocal cosecant. So this is going to be equivalent to negative tangent of our reference angle, our acute angle. And 150 degrees in quadrant 2, to get the reference angle, we take 180 minus 150, and that's 30 degrees. Negative tangent 30, look up. Tangent of 30 degrees, remember tangent is equivalent to sine over cosine, so it would be the square root of 1 over 2 all over the square root of 3 over 2, but remember they have the same denominator, so that'll divide out. So we're really looking at the square root of 1, which is 1 over the square root of 3. So this is 1 over square root of 3. Let me bring down my negative. Oh, sorry about that. There we go. So it's negative 1 over square root of 3. And let's just rationalize that denominator. We'll multiply by square root of 3 over square root of 3. So we end up with negative square root of 3 over 3. That's our exact value. Okay, so it might be a good thing to, at this point, pause the video and try the next 3 on your own. All right, so sine of 5 pi over 3, convert to degrees, multiply by 180 over pi, that's 60. So this is equivalent to the sine of 240 degrees. 240 degree angle, its terminal side lies in quadrant 3, where sine is negative in quadrant 3. So sine of 240 is going to equal negative sine of 240 degree angle. If I subtract 180 from it, I'll get the reference angle of 60. So it's equivalent to negative sine 60. Look up at the table. The sine of 60 is square root of 3 over 2. So this is equal to negative square root of 3 over 2. Is the exact value of sine of 4 pi over 3 radians. Number 5, cosine of 2 pi over 3 will convert to degrees, multiplied by 180 over pi. 3 goes into 180, 60 times 2 is 120. So this is cosine of 120 degrees. 120-degree angle is in quadrant 2, where cosine is negative in quadrant 2. The reference angle would be 180 minus 120, which is 60. So we have negative cosine of 60. Cosine of 60, looking up at the table, or your special right triangle, whichever one you prefer, that is the square root of 1 over 2. The square root of 1 is 1, so that's simply 1/2. And don't forget, let's bring down the negative. So negative 1/2 is the exact value. Number 6, the tangent of 5 pi over 3. Convert to degrees. Multiply by 180 over pi. Pi's divide out. 3 goes into 180, 50. 50 times 5. Nope, let's try 60. 60 times 5 is 300. So this is the tangent of 300 degrees. 300-degree angles in quadrant 4, where tangent is negative in quadrant 4. So this would be equal to negative tangent of the reference angle. That's 360 minus 300, which is 60. So it's equivalent to negative tan 60, and the tangent of 60 degrees would be square root of 3 over square root of 1, which is simply square root of 3. Bring down the negative. So negative square root of 3. Okay, so there we were finding the exact value of the trig function given the angle in radian measure. Now we're going to find two values of our angle theta in radian measure given the exact value of the trig function. So kind of the reverse. All right. These are the steps. We're going to use all students take chemistry to write down the two quadrants our angles will come from. Determine the acute angle measure, in other words, the reference angle, that has the given exact value. Use the following formulas for the quadrants to determine the degree angle measure. Right, if we're in quadrant 1, our reference angle is our angle measure. If we're in quadrant 2, we take 180 minus our reference angle. If we're in quadrant 3, 180 plus our reference angle. If we're in quadrant 4, 360 minus our reference angle. Okay, hopefully this should sound familiar because we did this as well in chapter 9. And then once we have our degree measure, then we'll have to convert to radian measure by multiplying by pi over 180. All right, so we want to find two values of theta, theta being an angle measure, right, in radian measure. And theta has to be greater than 0 or less than 2 pi. So first we have the sine of theta is equal to square root of 2 over 2. Using all students take chemistry, so this value here, the square root of 2 over 2, this is a positive value, right? It's positive. So using all students take chemistry, sine is positive in what quadrants? Sine is positive in quadrant 1 and quadrant 2. Quadrant 1 and quadrant 2. Okay, well what angle, what special angle, a 30, 45, or 60, has a sine value of square root of 2 over 2? Let's look back up, right? 45-degree angle has a sine value of square root of 2 over 2. So our reference angle is 45 degrees. All right, this is our acute angle. So our reference angle is equal to 45 degrees. All right, so in quadrant 1, our reference angle is our angle in degree measure. In quadrant 2, we take 180 minus 45, which is 135. Okay, so these are our two angle values. Now we just want to convert them. We need to convert them to radian measure. So we take our degree measure and multiply by pi over 180. And if you need to, just take 45 divided by 180 on the calculator, math bracket, okay? This is going to be equivalent to pi over 4 radians. And do the same with 135. Take 135 degrees and multiply by pi over 180, right? And if you need to, All right, let me show you on the calculator. I'm just going to take 135 divided by 180. 135 divided by 180 is 0.75. And then math, crack, 3/4. So this is equal to 3 pi over 4, right? The fraction 3/4, and then don't forget your pi symbol. So here are our two values of theta in radian measure. Next, tangent theta equals square root of 3/3. Okay, this value here is a positive value. Tangent is positive in what quadrants? Tangent is positive in quadrant 3 and quadrant 1. All right, I don't have too much room here, so I'm just trying to keep everything. Should have said quadrant 1 and 3. Doesn't matter though, that's fine. What angle has a tangent value of square root of 3/3? All right. Remember, tangent sine over cosine. This would be square root of 1 over square root of 3, but then when you rationalize the denominator, you would end up getting square root of 3/3. So 30-degree angle. Right? The tangent of a 30-degree angle is equal to square root of 3/3. So our reference angle is 30 degrees. Well, in quadrant 3, we would take 180 plus our reference angle, right? Looking up here, 180 plus our reference angle, because we have to do 180 plus 30 more. So 180 plus 30 is 210. And quadrant 1, our reference angle of 30 degrees is its own angle. All right, so these are my two angle measures in degrees. And now we must convert to radians. So multiply by pi over 180. Ooh, I know I can reduce here. 30 goes into that 7 and 6. So that's 7 pi over 6. Come on, you gotta love fractions here. And 30 degrees, multiply by pi over 180. 30 goes into 186. So that's going to be pi over 6. And there are two radian measures. Next, cosine of theta equals 3 pi, or excuse me, square root of 3/2. This is a positive value. Cosine is positive in quadrants 1 and 4, right? Quadrant 1 and quadrant 4. So now, what angle has a cosine value of square root of 3/2? I love this trick table. 60 degrees. Oh, no, that was sine. Okay, 30 degrees, right? Square root of 3/2. So our 30-degree angle. That is our reference angle. It's in quadrant, so it's its own angle in quadrant 1. In quadrant 4, we would take 360 minus 30. You don't have to show this each time. That's 330 degrees. And now take our degree measures, convert them to radians by multiplying by pi over 180. Nice, that's pi over 6. Right, that reduces. And 330, 30 goes into 330 11 times. Ooh, I did the reducing already. So that would be 11 pi over 6. So there are two radian measure values. All right, now we're getting to some negatives. That's all right. That means if our quadrants are going to be different. Okay, sine theta equals -1/2, right? This value is a negative value. In what quadrant is sine? Quadrants is sine negative. Sine is negative in quadrants 3 and 4. So quadrant 3 and quadrant 4 is where our two angles will come from. But we need the reference angle, okay? So getting the reference angle, that's the acute angle. So in this case, you're not looking at the negative, just the 1/2, all right? So what angle has a sine value of 1/2? Sine value of 1/2 is 430 degrees, right? Square root of 1 over 2 is equivalent to 1/2. All right, so our reference angle is 30 degrees. And in quadrant 3, a reference angle of 30 degrees would be coterminal with an angle measure of 180 plus 30, which is 210. And in quadrant 4, to get our angle, we take 360 minus our reference angle, which is 330. All right. And 210 degrees converted to radians. Again, I'm dividing each by 30 here. 30 goes into 210 7 times, 7 pi, and 30 into 180 6 times, so 7 pi over 6. And same thing here, reducing, dividing by 30. 30 goes into 330 11 times, and 30 into 186, so 11 pi over 6. Number 11. Again, you can stop the video and finish up on your own if you like. Tangent theta is equal to negative square root of 3. Negative value here. Tangent is negative in what quadrants? Quadrant 2 and quadrant 4. Right? It's only positive in 3 and 1, so it's negative in quadrant 2 and quadrant 4. One angle has a tangent value of square root of 3. Tangent value, that's going to be sine over cosine. So that would be square root of 3 over square root of 1, so 60 degrees. So 60 degrees is our reference angle. So in quadrant 2, to get our actual angle, we take 180 minus 60, which is going to be 120. And in quadrant 4, 360 minus 60, which is 300. This is our angle measure. So now we convert to radian measure by multiplying by pi over 180. Dividing by 60, 2 and 3, so 2 pi over 3. Dividing by 60 here as well, 5 pi over 3. All right, and our last one, cosine of theta is equal to negative 1/2. This is a negative value. Cosine is negative in what quadrants? Quadrant 2 and quadrant 3. Okay. And what angle measure has a cosine value of 1/2? Cosine value of 1/2. Cosine, that'd be square root of 1 over 2. 60 degrees. Okay, so our reference angle is 60 degrees. In quadrant 2, I would take 180 minus 60, which is 120. For quadrant 3, 180 plus 60, which is 240. And now let's convert to radian measure by multiplying by pi over 180. Oh, nice, reducing by 60 again, dividing each by 60. That's going to leave me with 2 pi over 3. And same here, dividing by 60, that's 4 pi over 3. So there we have our 2 radian measures. Oops, sorry about that. Okay, that's it for tonight. Thank you very much.